This is an introduction to section 17.2 and also to section 17.3. In this chapter of the book, we're looking at kinetics for a rigid body. We looked at kinetics for a point particle back in chapter 13. In chapter 13, we had Newton's second law, which we have again here for the rigid body. That's here in your book. And for the rigid body, Newton's second law says that the sum of the external forces acting on the rigid body is equal to the mass of the rigid body times the acceleration of the mass center. So the important thing for the rigid body is that the acceleration you're looking at is the acceleration of the mass center. You can read through the derivation on page 424, and that derivation gives you equation 17.7, which says that the sum of the moments of the external forces about the body's mass center is equal to the moment of inertia for the body about an axis passing through the mass center, and it's the moment of inertia times the angular acceleration. So equation 17.7 we'll be using when we sum up the forces about the mass center, or when we sum up the moments about the mass center. However, there are times when, instead of using equation 17.7, you'd rather sum up the moments about a different point P, not the mass center. So there are cases when we would rather use equation 17.10, so you can use either one. And in fact, in your book, the first example problem that they give you after this, they show you how to do it using equation 17.7 or using equation 17.10. Equation 17.10, when you're summing up the moments about point P, this is equal to the sum of the kinetic moments about point P. The kinetic moments are found by using the mass times the acceleration of the mass center. You find the moment for that, and also you find the kinetic moment for the moment of inertia times the angular acceleration. In section 17.3, we're going to be looking at problems where there's translation but not rotation. So if the object is not rotating, the angular acceleration is equal to 0. So in this case, equation 17.7 just is the sum of the moments is equal to 0. Okay, and you can do that with x and y components or normal and tangential components. Okay, and you should read over everything in section 17.2 and the beginning of 17.3, but pay particular attention to what is in the green box here. And that concludes our introduction to 17.2 and 17.3.